Today was really tough. So we were really banging our heads against this PID subsystem and PID controller and PID command. Reading more about it, and we found better articles that really dove into some of the details of not just how to use it, but also what it is and how it affects good motor control. That you should totally read about as you go through all of this stuff um, is like a heater. When it's really cold, the heater gets turned on and it heats up the room. And then when it gets hotter than what it was set to, it cools off. Or maybe it turned off right then when it detected it, but it took a while for the heaters to cool down. And so it overheated the room a little bit. And so it stayed off for a while until it got cold enough for it to trigger back on again. And then it turned off. So it sort of oscillates as it tries to get to a stable room temperature. Spinning our robot, we don't want to jerk it entirely around and then hard stop necessarily. We might want it to um, uh, slow down its turn proportional to how far away it has to go. So as it gets closer, it moves slower. So that's the sort of the P in PID. Um, and so read up about it and see how much you can get your head around it. What we're trying to do when we press the X button on our controller, that it executes this command to spin around. While we're doing that, we're trying to make sure that we organize our code in the best way possible. But really, if we can get any way to do it, that'll start us off, and then we can make it tidier and more and better organized and following best practices, and so that our code base will get smarter over time. But let's just try to press the X button and do an about face. That we tried just by slapping together code, not really looking it up, just by using sort of like, well, we knew we had a gyro, and we found out how to create a gyroscope, or access the one that's plugged into the Robo Rio, and so and you can get its current angle. So we just thought that this command, when it's initialized, will set our target equal to whatever the current angle is plus 180 degrees. So cool. And then we will turn on our drive. We'll activate the arcade drive, not by how usually we put the current state of the controller and um, one axis up and down, and left and right. And so what we are doing instead is just saying give the motor half power. I think this turns right, negative would turn left, but I'm not sure about that. We would have to experiment. And then we would uh, we would say, okay, if the current angle of my gyroscope and the difference between where I'm at and the target is less than like 5 degrees, that's cool. Trigger the end command. Or I'm not sure if that's the correct way to end a command. Um, but let's say it is, and then we hit the end command, and after is finished returns true. So maybe we have to say is finished, or anyway, we'll have to uh, test that. So that should probably instead read that. So, am I less than 5? And so this is a magic number. We shouldn't hard code it here. We should put that up here. These are key little numbers we just made up that we might want to tinker with later on. And so we shouldn't have them buried in the code. We should use a variable name that's actually set up here. And so we would just change the magic number at the top of the file, not have to go through multiple references to a magic number. Okay, small point. But so anyway, this is not set up correctly, but that's the idea, is that we this would constantly be called execute. It's repeatedly called, and so it's going to maintain uh, half an energy to the drive until it sees this, and then it would somehow terminate. And through a lot of really cool teams that have also published their code just like we do. Um, and I've been looking through, and I'm really impressed with how Team 3494 have organized their code. It's really simple. Other teams have done fancier things, certainly, but this team seems very clever, but also very simple and easy to understand. Um, and I think this angle drive command um, really makes a lot of sense. Drivetrain is able to set an angle destination. Um, and that I think sets some of, because the drivetrain has an interface in which it uh, at least as an aggregate objects, the motors that make up the drivetrain. Somewhere in there, there's an interface for a PID output, and this is the angle helps constitute the PID source, meaning if you read the articles where it really talks about what is being driven to where. And so we're initializing these things here. And then the execute, very similarly to how we just guessed, is applying the arcade drive, not by half speed like I did, but by a PID tuner, which is really clever. This is what we need to study up on, and so we should follow this back in code and see how this is set up in the drivetrain and how the drivetrain configures its PID. Very cool stuff. And then true, I'm not sure what the override is. I mean, what the this overloaded method with a third parameter is. We were only using it with two, but actually there's an easy way to find out. If I just go to this arcade drive, why is this one lowercase and this one uppercase? Did they overwrite? Did they make their own arcade drive method? That's weird. Oh, hold on. I'm going to get distracted for a second as I investigate this. So these are, I'm looking for subsystems. I would like to see the drivetrain, and that's what they, that I should have just duplicated this. Duplicate so I can get the other file at the same time. And that was not command, yeah, autonomous command angle drive. They've got really well organized. Okay. So we've got this arcade drive capital A, and the drivetrain, what kind of object is it? It's right from the robot.java. So this drivetrain is a PID subsystem. Okay, so that's key. And then in robot.java, because we're accessing robot directly to get the drivetrain, yeah, we're accessing the robot directly to get the drivetrain. And so the drivetrain being created right here. Its constructor being triggered right here. So it's going to have to start here that our drivetrain, we're going to have to really commit to making this. We tried to undo it after the PID system wasn't working out. We tried to see, can we force it the way, just using our own 2 cents, setting this to a normal drive the way we understand it best, and getting the 180 turn to operate the way that it is. Not really. It doesn't look that way, and it looks like we're going to create a lot of extra problems when the best examples that we can find really do base the drivetrain off of a PID subsystem. Doesn't mean you have to use the PID all the time. So let's change this back to PID subsystem. Find out and research what motion profile status is used for, because looks mighty relevant. I'll add a to-do here, and that's just research motion profile status, and this is where it would go inside the constructor, right? That's inside, no, that's as an instance variable, not as something inside the constructor. It'd be right here. These are all the instance variables. So we can see that the PID tune is set here. It's declared here as an instance variable, and then after the motors are all wired together, yeah, this is interesting with the whole motion profile status. After these are all wired together, then the PID is configured. Not sure what this comment is all about. Thought the deadband elimination is being processed in the periodic. Maybe it should be handled in a drive command, but we'll get to that. Meanwhile, we also need to do and that's config whatever this is. So that's about where we would see it. Processing the motion profile. They have their own arcade drive. This is interesting. So it was their own custom method that they've built here. And so it's applying deadband and doing a whole lot of stuff here. This is really neat. So they're not using the differential drive that we created, right? They're controlling the left and right motors without creating the differential drive that we wire together here in in the drive file here. So I wonder why they're doing something different. That's also something that we can start researching into more. So I think that'll give us a place to start. You know, the old rule is if you don't know what to write in code or an essay in anything, then you haven't read enough. And so I think we've got a couple to-dos here that we should chase up on and try shifting. Well, we know we're going to go into a PID subsystem. So let's research a motion profile status. Let's research why someone might not use differential drive. And so these might be helpful things that'll help fill in the picture and allow us to take over and better control when trying to implement some of this PID stuff.